Let's take a look at question 5. We are to find the equation of the tangent and normal line to the curve at the specified point. So the curve under consideration is a curve with equation y to the 5/3 plus x to the 2/3 equals 2 at 1, 1. Okay, so in order for us to write down the equation of the tangent and the normal lines, we simply need um, a point and the slope. Okay, all right, so I'm going to call my tangent line L of x, and that will be f of a. Let's do f prime of a times x minus a plus f of a. Okay, that will be my tangent line. And then my normal line, let's call that, I'm going to call that n of x. Okay, so that's going to be, of course, if f prime of a is the slope of your tangent line, the negative reciprocal of that will be the slope of my normal line, x minus a plus f of a. Okay, all right, so all I need is the point a and f of a and the slope to write down the equation of my lines. All right, so we already know what a is. A is the x coordinate, and f of a, which is the same thing as y, is the y coordinate, which is 1. Now what we need is f prime of a. The slope of the tangent line, basically we're looking for f prime of 1. So in order to do that, we are going to have to find the derivative of this function and evaluate it when x is equal to 1 and y equals 1 also. Okay, so let's go ahead and write down the equation. Y to the 5/3 plus x to the 2/3 equals 2. We're going to differentiate this implicitly. Okay, so if we differentiate this implicitly, we'll have, using the power rule here, 5/3 y to the, if you subtract 1, or 3/3 from 5/3, you'll be left with 2/3, plus, actually, since we're differentiating implicitly, we have to multiply this by y prime. This is the same as dy dx since we're differentiating with respect to x. All right, if we apply the power rule here, also we have 2/3 x, subtract 1 or 3/3 from that power, you have negative 1/3. Since we're differentiating with respect to x, there's no need for an x prime. Okay, the derivative of 2 is 0. Now let's go ahead and get y prime isolated. That's what the function we will use to calculate our slope. Okay, so to get y prime isolated, we'll subtract 2/3 x to the negative 1/3 from both sides. So we're going to have negative 2/3 x to the negative 1/3. And then we're going to divide both sides of the equation by 5/3 y to the 2/3. Okay, so divide this by 5/3 y to the 2/3. So if we simplify this, we are going to have negative 2, negative 2/3 times, because we have a negative exponent here, we'll have negative 1 over x to the 1/3 times 5/3. You multiply the numerator by the reciprocal of the denominator, and then we still have y to the 2/3 downstairs. Okay, so our final answer for the derivative, y prime is going to be, cancel out those 3's, we'll have negative 2 over 5 times 1 over x to the 1/3 y to the 2/3. All right, Now what we need to find is the slope at x equals 1. When x is 1, y is equal to 1, okay? So we're looking at for y prime evaluated at 1 comma 1. So that simply means we're going to plug in 1 for my x and 1 for my y. So we have negative 2 over 5 times 1 over 1 to the 1/3, y to the 2/3. And we can see that our final answer is negative 2 over 5. All right, so that's your slope that we are looking for. Okay, so going back to this equation we have right here, f prime of 1 is equal to negative 2 over 5. That's the slope of the tangent line. All right, so tangent line, go ahead and write it down. Tangent line, we decided to call it L of x is equal to f prime of a, which is negative 2 over 5, times x minus a, which is 1, plus f of a, which is 1 also. So this is the equation of my tangent line. You can call this y, f of x, whatever you want. I like to call this L of x. Now for our normal line, everything else will be the same except the slope will be the inverse of this right here. Okay, so the normal line, let's call that n of x, is equal to the inverse is the negative reciprocal of negative 2 over 5. All right, so the negative reciprocal of negative 2 over 5 is positive 5 over 2 times x minus 1 plus 1. All right, so those are the two answers that we are expected to get. All right, let's take a look at the graphical significance of the result we just generated. So this is the graph of the function that we just, the function that we found the slope of the tangent and normal lines to, x to the 5/3 plus y to the 2/3 equals 2. So what we're going to do, let me show you the graph of the tangent line, okay? So there goes the graph of the tangent line. This point right here is the point 1, 1. All right, so this is the point 1, 1. And we can see that this line is tangent to this curve at the point 1, 1. All right, so that's the graphical representation of our result. And can you visualize what the normal line will look like? The normal line is going to go through this point 1, 1, and it's going to be perpendicular to your tangent line. All right, I just graphed the point 1, 1. So this is the graph of the normal line, okay? So that's the normal line to the curve, and we can see that it is in fact perpendicular to your tangent line. Okay, so that's the graphical representation of the result that we just got. All right, so we now have a graphical confirmation that our answers are in fact correct. So let's go ahead and box our answers, and we can advance to the next problems.